dude. I listened to you for 3 hours.
Because it's destroying the celestial
Say the
theodolite.
same shit over and over, and all you do every time is say, "Yes, refraction is the same no matter what." That's what
You're going
all
back
you
to the
said.
Globe electric. That's what's going to happen.
No, I don't
He
think the
never with
solution
flat
to
Earth. He just likes
stellarium
to argue.
the
Oh no.
solution to stellarium is not the celestial theodolite. If you're going to solve the issue with flat Earth, you have to address that stellarium works for some reason.
But do you know that like we can't use refraction in these form? I don't think we can anyway, because the refraction formula is. I mean, they're basing it off making observations in the real world, and then assuming it's a globe, it's a sphere, and then when they see it at a certain distance and it's turned up or it's turned down, then they basically say, well, because it's a sphere, must be how much refraction's occurring in the atmosphere. So they just post hoc the refraction to fit the globular model.
That's
This
literally what
angle,
he's.
the
That's literally
angle
what
to
electric
the
doing
angle
in
on
his
the peak
argument.
to the star in this flat Earth trig prediction does not reflect reality. The angle to the star in reality is not 234 or 233 or whatever they're claiming it would be.
Yeah, it's like 255 or something from the peak with refraction.
It's closer. That's all it is. It's just closer. But what about? I mean, there's so many other ones that it just they just match. So what the fuck do you do with that?
Except when they don't, Rigger. Except when they don't.
Right, that's a motherfucker, isn't it? It's almost like
Yeah.
10% of them are wrong. Oh, what do you do
I'll
then?
show you what the results look like. Give me 1 second.
What do you do when it's like 10%? You just throw it out? Fuck it, throw them both out. Throw out
Hang on.
refraction, throw out
Where is
observations.
my...
Yeah, it doesn't matter if I think they're a flat or globe. You have to acknowledge that this celestial theodolite shit completely disregards things that are happening in reality.
Are you worried about refraction?
There you go.
I've asked you this before. Can you just be specific though? Are you concerned with refraction between the mountain and the observer? Are you
Yes.
actually worried about
That's
Yeah,
his whole
the
entire argument.
atmosphere.
So
The atmosphere has
one sec,
density.
just
Yes.
no worries. Yeah, cool. No worries, dude. I agree that it would be refracting, right? But both the star and the mountain would be refracting the same amount between the observer and the mountain, right?
Oh, yes. Sorry. Yes. But
Yes.
between the observer and the mountain, yes. But the star refracts
Thank you.
more than
So
the mountain.
So the line doesn't change.
not between the observer and the mountain,
Yeah.
only
Agreed,
between
yes.
the star and the mountain.
Yeah, agreed. Yeah. So, but
Great.
between the star and the mountain, both the star and the mountain refract 2 arc minutes, and then the star refracts an extra 11 after that.
But you agree, right, Roohif, that from the observer to the mountain, you're basically watching two images interact with one another. Yeah. So the peak of the mountain and the star at the distance, and you're looking at these two images at the distance. The refraction, both of those two images would be under the same amount of refraction, right?
Yeah, over that distance, over the 50 Ks, yes.
Between the observer and the peak, yeah.
Yep, yeah.
I don't know what's so hard about. I was trying to explain that to Electric earlier, and he was just going round and round in circles. So I don't know.
Because nothing you're saying actually matters, dude. Because your prediction doesn't match reality.
Hey, Taylor's here. Which reminds me, was what I sent you the other night useful?
I see. Zerba was on Heffron's house and they're turning the atmosphere off.
Hang on, let me bring it up as well.
Yeah, I'm not a big debater for the celestial theodolite because I'm not an expert.
All right.
So I wouldn't ask me for any reference. But I do see we got the okay. Did you try to put the observer at the mountain and see? I don't understand. I know Alan's responded to that argument, but I can't remember what he said.
All right, so in the chat, at 52 past, there's that graph. So that red line is doing the celestial theodolite. So putting the observer at the peak and turning the atmosphere off, and then comparing that to the raw flat Earth angle, and you get massive discrepancies for two of the mountains and large discrepancies for some others. The blue line is doing the whole thing properly. So you're at the observer, there is refraction. Yeah, that's it. And the star gets occluded at the same time or the same angle as a mountain. That's the deviation. The blue is the deviation for the globe.
So whenever they're trying to see when the star is occluded, you think that they should put their observer on the mountaintop? But
No,
how would
I
that
think
work with doing the trigonometry?
I think putting the observer somewhere where the observer is not is silly, very silly. But that's their method, and that's what I'm doing in the red line on the graph.
So you're saying you want the observer at the mountain looking at the star and taking a measurement with a theodolite?
That's what standard refraction is, though. What you just said, Roohif, is just claiming that it's standardized for wherever the observer is, no matter where you place them.
So
We think
Tayler,
that's absurd too.
Okay, you can think it's absurd to put the observer where the actual fucking observation is made.
All right, Roofie, let's try this. You put the observer, right, where he actually was in real life. Okay.
Yes.
Now, how do you measure the refraction?
Right, we assume a standard atmosphere, a typical atmosphere, which has
There's
been
your whole
measured.
argument. So you
Right,
just
which has been
guess
measured.
what we think it
No, it's
should
not a
be
guess.
because it has to. Yeah, I just explained to you how it's a
It's not a
guess.
guess.
Yeah,
That's based on measurements.
yeah, no, it's not. You're not measuring
Yes, it
anything.
is. We
It's
have
based
measured the
on
standard
measurements done
atmosphere.
somewhere else that are not consistent. The
Measurements made
results
all
are
over the
not
world.
consistent. Yeah, so the measurements made all around the world are not consistent
They
when you
show
do
a
experiments.
mean atmosphere, a typical atmosphere, Riga.
Yeah, but how do you know
Right.
it's
So they do
typical?
tell us what a
How do you
typical
know it's a
atmosphere looks like.
typical? How do you
What
know it's a
does?
So
typical?
just to be
Say it,
clear,
dude.
these measurements show you what a typical atmosphere looks like, correct?
What
Okay,
measurements?
so how do
Measurements of the
you
gradient.
know?
Wait, what measurements show us what a typical atmosphere looks like?
Weather balloon measurements, measuring the temperature, temperature, pressure, humidity on the way up.
There's no real typical, but whatever. Like if you
Yes,
delete
there
wind,
is.
yeah, if you
Yeah,
delete
there
wind,
is.
there's typical, but in reality, there's no real typical because
Okay.
that paper
Okay, bro.
explains to you how wind influences the light
Yeah.
Did you
Cool,
and
send me
how.
the weather balloon data?
I've probably sent you a link. Yeah, hold on. One sec. Oh, it's actually moved anyway. So here's a fresh link. Fresh link
It's
in
tough
the
too because
chat.
at mountains, the way
I don't know
the
where the chat is. I just tried to find it. So DM me the last two things
Live
you're
chat.
trying to show me.
All right. Right, yeah. There's that one. All right, so that's a link to the weather balloon data. What was the other thing? The graph, sorry. Copy image. There you go. Actually, I'll send you the spreadsheet as well.
So I have to get the app to look at your weather balloon data?
No, it's Dropbox, like same thing as the
Dropbox.com?
Google Drive. Yeah, no, you don't need Dropbox. You can download it or browse it, whatever, on the
It's telling me I have to get.
browser.
Okay, I'll try again.
Dropbox is such a great app, though. It's for so many cool things.
Yeah, you don't need the app.
Okay. So now where is it in here?
So the data, go into the data directory,
Mm-hmm.
and then every one of those files is the weather
It
balloon
says
data.
radio at the top. Radio?
Yep. Yeah, into radio and then into data.
Okay.
Yeah.
Then which one is it?
Every one of those files is weather balloon data for a radio sonde station in either the US, Canada, or where's the other place? Somewhere else, yeah. And there's about 200 of them, I think.
Is there any charts or graphs where you input this data?
Yes. Yep. Go back one directory, back into the radio directory,
Mhm.
and graphs.
Okay, hold on. It's kind of glitching out. Think I went back one too far. Okay,
Go
let's
back
see.
one too far. It shouldn't let you.
Mm.
Like, let me
Okay, I'm
test that.
still. Whenever I push the back button, it goes back to. Maybe it's better on like a computer. Must be.
Oh, you're on a thinger. Although it shouldn't let you go back one more directory. That would be a bug.
Okay, so radio under it, then what?
Graphs.
Graphs. Okay.
Yeah.
Then what?
Yeah, pick one of those that looks like it's got enough data.
Do these each correspond to the other data that you just showed me?
Yes. Yeah.
Okay.
So like CWOS, one of the top ones. Doesn't have a
I want
huge
to know
amount.
what math they use to get the refractivity gradient.
Yep, I'll send you that as well.
Okay.
Boom. There you go. CEDAW 1996.
And these didn't assume curvature or anything? Just like the
Correct.
terrestrial refraction calculation? Just basic
They're
refractive.
purely vertical. Yeah, purely vertical.
Cool. Okay, I'm reading your paper now.
The CEDAW stuff is in a lab, so it's not even.
That's really cool.
Not even
I'm
a
happy to
check.
hear that.
Yeah.
I have some data for you too on the refraction. I'm gonna get it together before presenting it.
All right, back to Balatro.
What are the interferometric refractometers?
Yeah,
They didn't use
measure
that, huh?
They did, yeah, in the CEDAW stuff, yeah. So the CEDAW paper took a whole bunch of other papers, the results from other papers, and sort of merged them into one better, more accurate formula. So most of those papers that he sourced, yeah, did use refractive interferometry. So like you send light along one path, and then send light along a vacuum, and the interference pattern tells you the refractive index.
Okay. Is there what is the number that is gonna tell you which way the light is bending?
Yeah, the gradient. So how much the refractive index changes with respect to height. Right. So if
So
you're
is that a
dense,
positive versus negative that would say it's bending
that's
up
a good
versus down?
question. So typically, it kind of they often leave off the sign and assume that it's getting less dense as you go up. If they need to be explicit, they are. But obviously, if you're more dense at the surface and less dense higher up, then light bends downwards and the apparent angle at which you see objects is higher.
But they
So you'll
acknowledge that
see,
light can bend up on the surface though.
yeah, of course. Yeah, that's what
Okay,
gives you
so
the
then there
freedom
should
of
be
motion.
like a number like differentiating which way it's being bent.
Yeah, whether the gradient is positive or negative.
Right.
And
Yeah, but what
it's
if there's
clear
multiple
from
aspects of the
context.
gradient? What if there's multiple
Multiple what?
aspects, and you have to take into account different measurements to get the overall density?
Yeah, if you can provide evidence that there's anything other than pressure, temperature, humidity,
No, I
CO2,
agree, but I'm
wavelength.
saying what if the pressure is one way, temperature is another way, humidity is another way?
Yeah.
Then you have to take
Yeah,
all
so
this into
pressure,
account
it
to
does.
get
That's
the
what the formula
density.
does. That's what the
Okay,
Siddle
good.
formula does. Yeah.
But then once you calculate that to see if the light's bending up or down, it should give you a different value. There should be a differentiating value in there to see which way it's bending.
Yeah, whether the gradient is positive or negative. So if the refractive index gets less as you go up, then light bends down. If the refractive index gets higher as you go up, then it bends up.
I know, but is there one value, like a refractive
Yeah, zero.
coefficient or something that
Oh, zero.
zero?
If the gradient is zero, then light doesn't bend.
No, I know. But if it bends up versus bends down, is there a clear? I
Yeah.
feel like there should be more clear definitions for that.
If the gradient is negative in that the refractive index gets lower as you go up, so less than zero, then light bends down. If
I
the
got you.
gradient is positive, so the refractive index gets greater as you go up, then light bends upwards.
Okay.
So the value you're after is zero.
I think that you understood my question, so I think that we're not really making any headway about repeating, the same stuff. But I think this paper was telling me that the refractive coefficient was. Are you familiar with the Gaussian refractive coefficient of
Yeah, so it's the K.
0.13?
Yep.
Well, this paper
Yep,
said that they've measured a negative 2 point something
yes.
near the surface. So I'm assuming the negative refractive coefficient would mean the light is bending up.
Yes. That's the
Okay.
what's that one in the lower atmosphere, the 30-meter one?
Mm-hmm.
Yeah, get away from the surface, pretty much.
You need to hop on one of your weather balloons then.
No, just on a hill. If you're trying to make a horizontal measurement, if you want it to be sort of
When you say the surface, like I don't know, do you expect them to float or what's going on?
no, just on the edge of a hill.
That's still the surface. I mean, I guess we'll never disagree on that, but on a
Yeah.
hill, you're still on the surface. I mean, it is what it is.
We've had this discussion, right? Where the
Hmm.
vast majority of the line of your sight is above the surface.
Do you have a ray tracing program where we can see how much the line of the sight's off the ground and how much that would be affected?
I could do some calculations, but not right now. I can tell you it's going to be fuck all, right? It's going to be fucking nothing.
You can say that, but
Yeah.
I'd like to look at those calculations or maybe some type of ray tracing program we can see, even if the observer and target is within a strong gradient, if the line of sight is not, then what's the result? That's the question.
So, yeah, but let's say your hill slopes off moderately steeply, all right, and you might have 100, 200 meters of strong gradient to look through. That's going to be nothing compared to your 40-kilometer line of sight.
You say, okay, well, I'd love to see the data. I posit that if the light starts out in a strong gradient, that light's going to continue bending up. It might even out with the line of sight, but still you're going to have that effect either way. And then also the papers I read say in the bottom 100 meters of the surface, like in the lowest to the ground 100 meters has like strong refraction. So even if you're on like
Yeah.
some sort of hill, if it's still within 100 meters from the ground, I mean, I still think you'd experience strong refraction.
It can be, but typically not. Yeah,
Okay.
the
Well,
paper
you
you're
just gotta
talking
measure
about is
that
the
data.
30-meter one, right?
Hmm?
The paper you referred to a minute ago is the one 30
No,
meters.
no. Well, a minute ago, yeah. Just now,
Yeah,
no. Just now is just other basic papers and books I've seen.
yeah, yeah. 100 meters is very safe.
Okay. Well, actually, I think I have a diagram that I saw in this paper with the 100 meters. See if I can find it. I have a sensor push, a weather, like device that I can attach to my drone. I can definitely get it up pretty high, at least 500 feet, but that's 500 feet might be kind of maxed out, but I don't know how far it'll transmit the data. That's the only issue, or else I'd go measure it myself. I have got some measurements though. I did some theodolite readings with the line of sight
GPS, though?
refractive data
You got
on my
GPS with
drone.
your drone? Yeah. So get a radio
Yeah.
son. I don't know how much they cost. Buy radio sonde.
Via what?
radio sonde, which is like a it's meant to measure the temperature, pressure, humidity, blah blah blah. Here's one on eBay that transmits. There you go. I'll chuck that link.
Damn it to me.
Well. Yeah. Yeah, so that transmits the data to the ground, which would be plenty. Like 500 feet's nothing.
Did you DM it or did you put in the chat?
Oh shit! Whoops, in the chat.
Because I can never go back and find it. It's chat.
It's
Okay, here it
live
goes.
chat right above the.
I know, but I'd have to remember where to go search it. You know.
All right. Anyway, damned.
Oh, that's pretty cheap.
Oh.
So, that's cool. Have you tried this before?
No, this is just what they send up with weather balloons every day.
How does it work?
It's got sensors that measure the pressure. Like I could make one with my little electronics lab, but yeah,
I got you. I'm just saying, like, do you get an app on your phone or something?
No, you'll just have a radio receiver listening to 403 megahertz there.
And what would it say or do? Like, what would I get?
Some protocol, yeah. There'll be some digital signal it'll send.
So Roohif, you see what I added to my silly little cartoon?
Hang on. Oops.
So this is something that I don't know if I've heard this brought up, but the elevation angle to the star at the base of the mountain is going to be the same from the peak.
Yeah, assuming parallel light, which I don't know if they agree with.
No, I'm saying like altitude doesn't change your elevation angle to a star.
Yeah,
Not
right.
until you actually get really high up, right?
Yeah, yep.
So like there's a correction for that, right? In stellarium.
Oh, not really. I don't think so, no. I mean, it would.
There wouldn't
push
even be
through.
one, right? Like changing your altitude from like 0 elevation to 4,000 feet elevation does not change the elevation angle to the star. That's
agreed.
That's
Yeah.
demonstratable in reality.
Yeah, it'd do it for the moon, but probably nothing else.
Right. So I could treat it as if the observer's at the base of the mountain, which completely destroyed, like this drawing just demonstrates it's all done. I mean, I don't want to say that exactly. It's just the angle from the peak in this weird, what do you call this, an orthogonal view?
Yeah.
Right. This presumption that the angle from the peak is going to match the angle from the house, presuming this flat earth trig, but the angle from the base of the mountain matches the angle from the peak in reality. It would have to be different in reality.
It's they've caught themselves up in using so much freaking globe geometry. It's comical. So yeah, you're right. They should. The star does in fact move 69 miles per degree in elevation angle, but their hypothesis assumes that it doesn't. But they're using stellarium, which assumes that it does. Like it's all over the fucking place.
That's why I get annoyed, because I think about stuff like this and it's like, how are they pretending this isn't just baloney?
Yeah, got a lot of fluff.
I understand all the contention about what is happening in the atmosphere. That's all valid. But this prediction of like what the angle is going to be in reality is just absolutely silly. It's not what happens in reality.
Correct.
All right, Marker, I guess I'm done showing this.
Big question though, should I go to the gym?
What time is it?
Today, 2:30, something like that.
It's not late.
2:15. There you go. Oh, yeah. Probably should. Oh, it's time. Fuck it. Yeah. All right. I got the gym. See you.
Someone else is up. I don't know.
Server win.
Worldwide debates.
Do you know who started that?
Riggs.
Oh, okay.
Yeah, I like it.
That's cool. Probably tired of getting kicked out of servers.
Yeah, I definitely know the feeling of what it's like to get kicked out of a lot of servers.
How did you ever get kicked out?
Well, the most recent time I got kicked out of Earth Awakenings, Jeremy was listening to me talk to Rocky Life, and I said, "You don't have a model." I was pretty much challenging flat. I was saying, "You don't have a model of a flat Earth. The only closest thing to a model is the A.E. Gleason's. Can't have a 24-hour sun on A.E. Gleason's, blah, blah, that dumb stuff." He's like, "Of course we have a model. I can demonstrate water being flat in a terrarium, and gas pressure. I can demonstrate all the conditions on Earth." And I asked him, "Where's Antarctica in your terrarium?" I said, do you want to know the lay of the land masses in your model?" And then he kind of like refused to answer, and I called him a cupcake, and Jeremy banned me. It's because I distinctly just said, "You're a cupcake," like super loud. It was just like, boop. I couldn't see the server anymore. But shit, like, these are things that I think matter, things we got to figure out. I got banned from EtherCos just because me and Shane just don't get along. Trying to get back into EtherCos, and I know these guys are just never gonna have me. I used to get muted a lot in Earth Awakenings trying to talk about when Wittek got
So
back
you don't
from.
believe in either model, right?
Yeah, both models have their own individual issues.
Okay.
I think that what greatly substantiates the flat Earth is the fact that oh man, I just had it. Sorry. I think necessary extraordinary evidence, like things that are really detrimental to how we understand and experience reality. Like when we go to make like a map and you want to start somewhere and you actually want to know the distance between 2 points and you like want to like accurately measure that, your points are coplanar. So XY coordinates are all like, latitude and longitude is all based on Euclidean geometry. Like you're just measuring lines between points. And then you could make a whole 2D grid map using that method. That's what surveyors do, planar surveyors. They make their little maps. There's no globe. It's just all based on Euclidean geometry and just angles. And actually like using, a squared plus b squared is c squared, and you're determining elevation change relative to 0, your benchmark, which is your coordinate plane. Which is all your coordinates are laying upon that plane. It's all 2D, right? So I think that's an issue for the globe. I think that's a big, big issue. That's extraordinary evidence that it's like most practical to treat the Earth as flat locally. And then there's also water being level. Gas pressure is, gas isn't escaping when it's adjacent to a lower pressure system. And yeah, like these are things that are really substantiating the case. And then there's some mistakes, like A.E. Gleason's map and celestial observations, 1 degree every 60 nautical miles. All these things are big issues for flat Earth. And then the globe has big issues. You can't measure the rotation. You can't measure orbit. Everything is like conserving the momentum of the reference frame. So you can't actually measure any of the forces that would be being applied to your reference frame to cause like Coriolis and all this silly stuff. You have to presume you're flying around. It's like a very counterintuitive to your actual experience. Like who really walks around like, "Oh, I'm flying through the universe. Where I just was, I'm no longer there. Even though I'm sitting in my chair and I appear stationary, I'm just flying around." It is actually like it's pretty much insanity. So I think that is actually a serious substantiation of flat Earth. There is really no practical reason to think you're flying around. You could actually have a geocentric globe if you really had to. Motion is relative in their model, so all the celestial objects could just be moving, relative to a stationary globe. The globe depends on it all, like moving and rotating and flying around the sun. It's just counterintuitive. And once you start elucidating all these issues and you see what's really wrong with both models, all you need for the flat Earth is for the stars to work. All you need for the globe is absolute fucking pseudophysics, pseudoscience to work. Like the globe requires things that you can't demonstrate. Lava, attracting water, just all kinds of stupid stuff. Emptiness of space, big bangs, accretion disks. gravity being caused by space-time, a bunch of stuff that I don't think makes great sense. I don't like the globe model. I actually like the concave model better than the globe. I like the idea that we could be in a rising bubble with cavitation at the bottom. I'm going to pull this picture up, and then I'm going to share my stream so you can know what I think the best concave model is. All right, here goes the bubble model. I shared my screen if you want to see. I don't know if you're still listening.
Mhm.
You can see my screen?
No, I wasn't looking.
Oh, sorry, I'm still sharing. It's just a picture.
Mhm.
All right, so this is my idea. I don't know if other people have thought about this, but I think about this a lot. So when a bubble rises through water, the buoyant force creates a cavitation at the bottom of the bubble. Like you could literally treat Earth as a rising bubble, and all your diverging plumb bobs and your changing elevation that seems to comport with the globe. Like they say that they're looking through these corridors of air and everything is dropping over distance. Okay, Flat Earth says this curved visual space, things drop because of perspective is something that is just the nature of optics, the nature of the eye, ball optics, because the lens is not like, perfectly symmetrical, then you're going to have like some hyperbolic visual space. And that's what happens when you are looking at anything. That's what causes drop over distance. Or, you could have this cavitation that is actually called, and we're all standing on here. This is where everybody stands. Everybody's plumb bob truly is diverging, just not as much as the globe says. Like literally what we observe in reality is that plumb bobs don't diverge at the exact rate of globe prediction, because what they're using to determine that their plumb bobs are diverging is the vertical angle to their theodolite that they think they know the elevation of relative to mean sea level, right? So they say that my theodolite over there is 5 feet above the ground, and my theodolite over here is 5 feet above the ground. If Earth is flat and water is level, then both of my theodolites are the exact same height above the water, and they both sight each other, and there's drop, right? That's what people observe in reality. People say, oh, it doesn't match the flat Earth prediction, that there wouldn't be drop. There is drop. So they say because there is drop, therefore my plumb bob must be tilted. They're measuring the vertical angle to the height of their theodolite, and they're saying, oh, it dropped. My plumb bob's diverging. So it actually doesn't even drop at the rate that it needs to. Typically, everything is refracted up in their model, so it doesn't match the globe prediction. The amount of drop that they see is like,
I can explain the whole drop
yeah,
over distance. It's really easy. All you have is a temperature gradient present on Earth. It's present every single day. It's called convection. The sun will heat up the surface of the Earth. The surface of the Earth, either way, is much warmer than the air above it. This would cause a negative density gradient on the bottom. This would make the light rays bend upwards and have an apparent drop over distance. I've plugged in temperature calculations that I measure myself to like basic refractive calculations, and you would expect to see drop over distance. So very open and shut case to me. I don't even worry about it anymore. I have a theodolite, and I've done measurements, and it's kind of what you'd expect to see with the predominant temperature gradient present on the Earth. This is why if you like track a mountain peak throughout the day, it'll get shorter. And multiple papers have tracked this, actually, peer review papers have tracked mountains progressively shortening throughout the day. And this is just because the temperature gradients are more prevalent. They'll get shorter. But yeah, so higher temperature causes lower density, and temperature is much warmer on the surface of the Earth than the air above it. That's why when you climb a mountain, it's much colder as you go up, so it's something predictable and it's repeatable. Sky Freeze made videos like introducing like warmer air to the surface using like a blow dryer or something, and I've seen objects in the ground merge into the ground, and yeah, you can repeat it yourself.
Yep, exactly. You literally just said it. That is the exact counter argument that needs to be brought up to the globe. Is like,
Well, I am,
what are
and I'm
the
actually
actual? Yeah.
compiling my data right now to present that, because I went and took a lot of temperature readings with an RTD thermometer, which is like a research grade thermometer. They're like $350 to $400, and I got one just to do measurements and plug in the data. And I plugged in the data. I got like a 1 degree Celsius drop per meter on the surface of the Earth. All you would need, if you just plug in data to basic refractive calculations, is a 0.2 degree Celsius drop per meter, which is like nothing. to have an apparent globe effect, like drop over distance at 8 inches per mile squared. That's all you would need. I think that's like a standard drop in temperature in like the bottom 100 meters of the Earth's atmosphere. And whenever they do these standard refractive calculations, they assume one standard temperature in the troposphere. That's the biggest joke in the world. We all know it gets colder as you go up in elevation. So plane windows will feel cold. Climbing a mountain will feel cold. But they assume one standard temperature, and they only account for the pressure increase. Once you do that, they're going to say there's a positive density gradient where it's denser on the ground because they're only incorporating pressure and assuming one temperature. Once you actually incorporate the temperature gradient that's present, you'll easily get a lower density near the surface, which will give you a apparent drop over distance.
Yeah, I don't know if you've heard me making this exact argument. I broke it down to Earth is life a few days ago.
Mm-hmm.
Yeah, dude, what you're saying is exactly what I was trying to say to Earth is life. I told him, at night the sun is absent, the air cools down. They treat the Earth like a black body, meaning it's going to absorb the radiation from sunlight. So first the Earth gets warmed up, and then the Earth's surface warms up the air. In their model, the air most adjacent to the surface is the lowest part of the density gradient. That's the first part that's going to get heated up. So once the sun comes out, that means that nearest the surface, that's where the less dense air is going to be as the sun is rising.
Mm-hmm. Even at night, the ground is still warmer than the air above it, but it's more prevalent during the daytime. And this is also present. It's called like conduction, where the Earth will like store heat. It'd be like conductive. And even on snow-capped mountains, you have this effect. Even on top of the ocean, like the top layers of the ocean that are
Yeah,
exposed are 30 degrees warmer
you know
than
how they
the ground.
counter this. You know how they counter this, right? They say that inversion is so close near the surface. It's not happening at 5 feet high or 6 feet high, like how they normally like to station like
It's
their optic
measured
at
to
six
myself.
feet. They say it's only happening 10 centimeters above the water. That's not true. It's
Not true.
actually happening. Yeah,
Yeah, I
exactly.
took research grade thermometers, like the highest precision thermometers, and measured, and I got like 1 degree drop per centimeter, even like 2.5 feet up to 5 feet. But yeah, I have these sensors that I use too. I can put one on the ground and one like 10 feet up, and I can't remember all the data. I'm gonna be compiling data very soon. I've been working on it actually the past few days with the temperature readings I've got, and I'm gonna try to use my drone and go higher in the atmosphere and measure my own temperature readings and stuff. But I know near the surface, up to like 10 feet so far from what I've seen, it's a very strong gradient. And
Oh yeah.
even if you're on top of a mountain, that'll still be there. And I
I
think
actually
it
meant to
extends
ask you
much higher
something.
than they say.
So
Where did they get the information 10 centimeters or whatever? Where did they get that?
yeah, they believe that the rapid change of the lapse rate near the surface is where you're going is, but that's where the sinking is because of like how quickly the heat, uh, you know, I'm not describing it correct. Sorry.
Mm-hmm. No, you're good. No, like it's definitely present higher because I measured it.
Right. That's what I understand about it. But there's some Globers that'll try to sneak that in and like, yeah. What was I? There was something else. What was I thinking?
All you need is a negative 0.2 degrees Celsius drop per meter. That's it.
Oh yeah, I was gonna ask you. So you went to the Salt Flats, right? What was the name of the place that you took your theodolite?
Bonneville, Salt Flats, yeah.
What do you know about the claimed geology of the land? Like, what do they say created this place?
I mean, I haven't looked into it that much, but they just say evaporation or whatever from a lake.
The lake evaporated, so it's pretty much like a basin.
And actually, the salt felt really cold to the touch because the salt is not very conductive. You can look this up. So that's why it feels cold when you touch it. And so, if anything, I should get less of a predominant temperature gradient there than anywhere else because the salt is not conductive. But I still measured a very strong temperature gradient near the surface, either way.
Yeah, I never really got to ask about how this experiment went. I'm actually really interested because I heard you say in passing that it matched the flat prediction. Was there any Globers out there?
Out where? No,
No Globers were there when you did this to like
but I
cross
recorded the
reference.
whole thing,
I believe it. Wow. Okay.
like 7-10 hours of footage.
Well, yeah. It's nice to hear someone else say what the important things are. You'll never hear a Glober admit to this.
Yeah, because they wouldn't have their theodolite readings as concrete as they think.
Shoebill his life is in disarray. Like we're literally taking
Dude,
away what he
it was
used to
so
observe a
funny.
globe.
I've talked to him about this before. He says, let's see. He's like, oh yeah. I'm like, when do you do your measurements, Shubo? He's like, I do them in the afternoon. Yeah, like in the summer in the afternoon. And I'm like, do you know it's like the worst time to do it, right? And he's like, no, it's not. And I was like, how do you know that? He said, because my observations match the globe the best. I said, you're not supposed diction, right? Because you're assuming globe, so therefore you can't use this as proof for a globe. But yeah, so he's like, they match the globe predictions the best in the afternoon. And so how can you use your, like, in order to say that here's evidence for a globe over flat earth, you need to equally test each model. If you're assuming globe in the start of the experiment, then you cannot no longer say that you're equally testing each model. So anyway, and then I was telling him, like, there's been people who's measured the temperature gradients at night versus the daytime. At night, they level out very, very stable. Like there's not like the strong gradient near the surface of the earth. And then during the daytime, there is. And we know that these gradients are what causes refraction. So wouldn't you acknowledge that nighttime has the least amount of refraction? If temperature gradients cause refraction, no temperature gradient at night, therefore nighttime has less refraction. But no, they won't admit that because things look taller at night. So they say there's upward, like things, there's more refraction at night because they look taller. But I'm like, but everything that would cause refraction would say there's not refraction. There's even other experiments using laser tests with less scattering at night to say, yeah, we had less light scattering at nighttime test in the daytime. So, I mean, every experiment showing there's less refraction when you start from like a bottom-up approach versus a top-down approach when you're making assumptions. I heard Globers the other day talking about the theodolite readings. They said, yeah, you can just go see how much refraction there is by seeing how far off it is from what you expect it to be. I'm like, how does that work? How do you know? Like, so you're just like you're starting with an end assumption. So how can you use this as evidence to test said end assumption? You can't use this as evidence for a globe if you're going to assume a globe right off the bat. And anything that deviates from that's refraction. That doesn't work like that. Science does not work like that, especially not if you want to use it as proof of, testing each model against one another.
I have this funny ass picture that Jesse Gordon made.
Yeah, I'm not a celestial theodolite expert or nothing like that. So I told Roohif when I got here that I did want to know what he was trying to say the other day, but I'm not going to like sit here and debate him.
Yeah, my current position about the celestial theodolite right now is that I honestly believe that Alan and Shane are trying to pander to a portion of the flat Earth audience that just doesn't understand like how celestial navigation works yet. Like they don't know the method. They're just appealing to like who they think understands it better. But honestly, those guys are, oh god, it's so annoying. Like I hear about it, I'm like, this deserves no attention. They're moving the observer, and they're pretending there's no elevation angle change when you get closer to the target.
Hello?
It's just, sorry, what's up?
Is there any way I can turn my camera on? I have camera.
I think you push that there's a screen share button, and then the camera button's to the bottom left.
Yeah, I do, but it says I have no video permission. But I would love to turn on my camera because I'm in a very cool place right now. I kind of want to show it off.
You'll have to talk to Riggs about that. I don't have any, I'm not a mod.
Well, why did they give the pretty girl camera perms and not me? That's my question.
I don't know. I just got here, so I don't even know how I got permission.
Well, because there's probably a bot. Or did you like confirm anything? Like verify or?
It told me I have to verify my email, but I didn't really do anything and just let me join.
You didn't boost the server or anything?
No.
Well, shit. I'm literally in a place that has a spiral staircase and a full-on bar in the fucking same room. And I would love to show it off, but
You can take a picture and put it in the chat.
Fuck that. I want to fucking get drunk off whiskey and shoot the shit with you guys.
Well, you can always do that, but
No,
if you don't have permission, then you can
that's no
just
fun.
take
Hey,
a picture.
Searsall, what's up? So, are we in here flat earthers or globe earthers, or what's the deal?
I would say a lot of people in here are globe skeptics, or at least they don't believe in a globe, right?
Globe skeptics, huh? Well, it depends where we're taking our measurements from. It would help if I had my camera on so I can give you a kind of visual perspective of what I'm going to describe, but I'll use my words to the best of my ability. It depends where you're taking measurements from. If you're skeptical of calling Earth a globe, there's probably good reason, and your underlying problem is the boundaries of the measurements that you're taking. And most people that define Earth as a globe define their measurements at the boundary of Earth's atmosphere and the vacuum of emptiness around it. And that's where my problem arises. The fact that I don't believe there is a vacuum of space around Earth's atmosphere. I believe there is an endless sea of energy that resides outside of the boundaries of what people call the atmosphere. So if we're measuring Earth, what you got to realize is that everything outside of the atmosphere is an endless sea of energy that is directly intertwined and connected to Earth. So why draw your boundaries at the atmosphere at that point if you know that everything outside what you measure as an atmosphere is actually directly connected? And it feels like we're measuring the wrong thing. It feels like we're trying to get to the same conclusion, both flat earthers and globe earthers. They're trying to reach the same conclusion. Why are we here? What is existence? What do we live on? And we got to get to the bottom and the fundamentals of all of this. And we got to really know what we're measuring. What we're measuring is energy itself. And there's a lot of unknowns, disinformation, and distractions from where energy comes from. But there was a man that lived long ago, about 200 years ago, by the name of Nikola Tesla, and he was very focused on where energy came from. And he was able to create the concept of alternating electric current, also known as AC, just because he believed in the concept that all energy that has ever existed in a three-dimensional realm all came from a singular source. Because of that, he was able to create, that's some of the best, most influential inventions ever. And both globe earthers and flat earthers need to kind of zone in on a story like that and focus on a story like that a lot more than they should be focusing on who's right and who's wrong. Is it flat or ball? They're zoned in on the wrong questions. They're completely asking the wrong questions. It will lead them nowhere in the grand scheme of things. And that's why I'm here. I want to throw the idea out there that maybe the models of reality that were sold to us are wrong, and we need to improve upon our current understandings, regardless of what the understandings are. I don't care if you think it's a fucking ball or you think it's flat. I'm concerned why you're taking your measurements that way, and why aren't you focusing on the fact that there could be a unified field out there that all energy is coming from. That's like way better of a question than is it flat or is it a ball? Like that is monkey see, monkey do type of thinking. It's just low IQ bullshit. So if I can get camera perms, that'd be great. No? Okay. Oh, you're server muted, Searsall? Fuck. You probably said something that a guy didn't like. That sucks. I want it server muted.
I'm gonna do this super remedial idea just because I think it's super relevant.
Sure.
We were talking about refraction.
Okay. What about it? What about refraction, electric?
I was talking about how the temperature gradients on Earth that I've measured personally and calculated, standard temperature gradients would make things appear to drop over distance.
Yeah, that's pretty sexy and all, but why are you doing that?
Well, people told me that if I buy a theodolite, I'll be able to prove the Earth is a globe. So, I got a theodolite and I did some measurements and I wanted to make sure I counted for all the variables. And whenever I did that, I said, like, there's something here, like the temperature gradient would give a lower density at the surface, making it appear to drop over distance. But then we can't, conclusively say that that isn't necessarily dropping physically, because whenever you take the temperature and pressure to calculate density, you'd see a lower density at the surface, which would make things appear shorter over distance or appear to have bottom-up obstruction, just based on principles of optics and refraction and density.
All right, so
But I guess what I'm wondering is why are you pursuing an experiment like that? Like, is there a greater purpose or maybe an answer you hope to discover, or at least a direction you could point me in to kind of gauge why you would do something like that?
Yeah, because they told me that, I'd be able to see that the Earth is a globe and I wouldn't have to question it anymore if I got a theodolite and did these measurements. But then whenever I counted for the variables, I said, well, this wouldn't, even though it might appear to be dropping over distance, that's what we would expect with the temperature gradients present each day.
And Tayler, your gears are thinking. But let's say you do a million experiments that disprove that the Earth is a globe. What would that lead you to? Use your imagination. What do you think type of conclusions would arise in your mind after disproving the globe so many times?
Well, I would wonder how the Earth got here. That would be the next question.
can I get into my thing? Because I'm sharing my screen. I'm trying to show something about why the globe is
Depends.
fucking
Can I
baloney.
turn my camera on?
I'm gonna break down why the globe is baloney.
Rigs right there.
But before you do that, Electric, can you have the ability to turn my camera permissions on?
I don't have that ability.
Well, fuck me. Sure, go right ahead.
All right, cool. So, right, we got the angle of incidence right here. This angle is due to the density of the medium, right? This is the density gradient, right? You got a vertical density gradient. Pressure,
No, this
the density is changing, right? The air is less dense than the
yeah, but
water.
I'll tell you right now, what you're describing is only going to lead you.
Wait, let me finish, dude. I'm just breaking
Yeah,
down,
I
like,
will.
I'm just breaking down this basic ass principle, and then it's
Yeah.
gonna move forward real fast.
Okay.
So, light bends down towards the denser medium, right? All right, let's picture a globe. My bad, I meant to have a different tool. Let's picture a globe. So on the globe model, right, you got your big globe Earth. Try to pretend that isn't really there. And
That's not a globe. What did you just draw? That's not the shape of a globe.
all right, I can fix it 1 second.
Yeah, that's not even remotely close to the shape of the circle.
I think he's working on it. Give him a moment.
Yeah, but a second grader can draw a circle.
All right, here's the surface of a sphere.
Not off to a good start.
Here's the surface of a sphere, right? Okay, so
Okay.
you have an observer, right? It's right here. Boom,
Perhaps.
hello. That's their head. The globe says
I'm going to be judging you based upon your mind's ability to actually draw out the concepts you're visualizing. And if it looks like a bunch of stickmen, then what I'm going to judge from that is you can't accurately draw what you're visualizing, which probably tells me that whatever thoughts you're speaking are not really thought through clearly. But,
Okay, you don't have to be like that. Let's just chill.
Yeah, that's fine. All right,
He's
so we
trying.
have a cross with a circle.
yeah, I'm making the globe more distinct for you because I think what you said is relevant. So I'm going to more accurately represent the globe model. 1 second.
There we go. Yeah, appreciate that.
My bad. I'm having a little trouble. Sorry.
Are you high?
I had an edible earlier.
Oh, fuck yeah.
Okay, here's the globe, right?
Yeah.
So
There we go.
So the idea is that just like this density gradient with the fish above, right? There's a consistent density to the water, right? And
Perhaps.
the only real difference in density is between the air and the water. That's what's causing your refraction. The angle of incidence is happening
What's
between
causing
the air and the water. It's not talking about a pressure gradient in the water. that's creating what would be more like a curved path. It would actually be like this in the water.
What's causing the difference in density, though?
You see what I mean? If there really is a pressure gradient in the water, then that's what the path of light would actually be doing. It wouldn't be a straight line, right? You see what I mean?
What?
I just drew a curved line where the angle of incidence is between the air and the water. The pressure gradient is a difference in density.
Can you
These are
describe
more
why?
angles of incidences in the density tower gradient. This is what they're saying is bending the path of light around a globe, right? So you got a target. What's the target?
What?
Let's say it's a star.
I'm
Star appears
confused.
on
I'm confused.
a star appears on the horizon, right?
So could you accurately describe why a light would bend through water?
Why does light bend through water?
Yeah, at a different rate than how it would bend through a different medium.
It doesn't matter why it's observed. You can measure it.
Oh, apparently that doesn't matter. Okay.
Well, yeah, why it happens, I'm not going to say I know why, because that has to do with like the fundamentals of the mechanics
And
of
you
physics.
don't know that, and that's okay. That's fine.
I don't think I ever could know why it is the way it is. But
That's
how it
totally
works.
okay.
Yeah,
It's totally okay.
that is the case. You can measure this to be the case in a laboratory. On the globe, I drew the star too big. This is taking me a long time. Sorry.
Why? Why is it taking you a long time?
Because this idea is fundamental to a globe. The globe has a lot of ad hoc realization, post hoc realizations in it. So because my bad. Because you're looking really far, right? And your line of sight, like let's say you want to station your line of sight level, perpendicular to vertical. The position of the star appear, man, you fucked me up, dude. You messed up my train of thought. That's okay though.
All I did was
So
ask
this is actually every change in the density gradient in the atmosphere is bending the light. That's what they say in the globe model. They say that what they actually say is that it's dependent on the volume.
The volume of what?
The further you look on the globe, the more things become refracted.
Why does it appear to refract?
Hold on.
Sounds like you're repeating. Don't really know.
I think that in terms of the celestial theodolite, I think that on the spreadsheet, Alan, or I think he already had one, like a column for the globe prediction with and without refraction, and the timing of the star didn't match either of them. So I don't know. That's just what I've heard him say.
Oh, higher the angle, farther the lower target, lower angle, closer, higher target. Oh, so basically what we're getting into is the science of how the eye perceives three-dimensional energy in front of it. That's what it sounds like we're fundamentally getting down to the science of. Because everything we're measuring, given this experiment, the root cause of it is perception itself. That's the verb that we're working with. And we want to figure out how perception works. And perception appears to warp things drastically. Just because your perception will warp objects does not mean that there's a curve. That does not mean Earth is flat or a ball. That's just the fact.
Okay, let's pretend that what Jesse Gordon drew right here is accurate. Let's put an observer
It is
somewhere.
accurate. It is 10,000% accurate.
Sure it is. We're gonna pretend it is for now, right? We're pretending like this is correct.
I'm not going to. It's not pretending. It is correct itself.
So this is what they're saying. So you got your.
Because that is what's happening. That's all because of the way the eye is designed geometrically.
Okay.
That's the only reason why that phenomenon is observed, is because the eye is geometrically designed a certain way. So when you perceive three-dimensional energy in front of you from a higher angle, the target from a farther distance, is going to appear lower.
All right. So just like the fish tank, when we say that the angle of incidence that's refracting the light is happening between the air pressure and the water pressure, that's where the angle of incidence is occurring. When they're looking through the air, and the atmosphere, they consider that, at every different altitude, I'm going to draw these lines, that this altitude is a different density than this altitude and this altitude, so on and so forth, right? As you gain altitude, the density decreases.
Yeah,
So
so I
this
have a
is pretty
question.
much your density tower gradient that I'm drawing. And then
Where,
you have your
I have a question.
and then you have your visual space. Oh shit.
I have a question. If you continue to go on, I'm gonna get more and more confused.
Okay, sorry.
Yeah, where does pressure come from?
Bro, what? Where does pressure come from?
Yeah, because you just used the term pressure in this little example that you're trying to convey to me. And if we don't truly understand the fundamental concept of pressure, and let alone where it even comes from, then you don't know what you're talking about. You truly don't. And it would be completely okay with me if you were just honest and don't know what the fuck pressure is, and you would just say that. But it doesn't sound like you're very honest, and you don't know what pressure is really coming from. A lot of people don't. If we truly understand what causes a force called pressure, then we would actually get to a lot more truth than you think regarding what you're talking about. So
Dude,
can
we
you?
measure the density tower gradient every single day. Every single day we send barometric pressure gauges up into the atmosphere to
You do?
to take weather data. They're measuring the temperature, the air pressure, and crosswinds. And these are like
Yeah.
instrument packages. Yeah, it's just a bunch of gauges, right?
Yeah,
It's just
they're
gauging
gauges
pressure.
based upon perception, but you got to understand what you're perceiving truly, objectively, without your subjective perception to begin with. Otherwise, your perception is going to lead you down a rabbit hole that is just going to take you down a bunch of different delusions and theories, and all those theories are not going to be based upon anything other than subjective reality, and that's not a very good fundamental kind of building block to work with.